Continuing on in 7.2, we're actually talking about conjugates again. If you remember, we mentioned it and touched on it in chapter 6 before our last break. And I told you we'd be coming back to it. And FOIL really shows what conjugate does. Just like the last example, here in example 2, I've already worked out B as if we were using the FOIL method. So what we can see here is we have 3x plus y times 3x minus y. In other words, we have the same polynomials, except we have opposite operations. We're adding one, subtracting the other. When that happens, we have the same first term, the same last term in both polynomials, but opposite operations. It's a conjugate. What happens is that middle part that we multiplied by 2 on the last example actually cancels out to be 0, and we can actually see that right here. Our outer becomes negative. There we go. 3xy, and our inner becomes positive 3xy. We have opposite terms, so they actually sum to 0, as it indicates here. And if we have plus or minus 0, it doesn't change anything, so it just kind of drops off because we're not going to write it. And we have 3x minus y squared, and really all that is a squaring of the first term and a squaring of the last term. So if you notice, your first term and your last term for both polynomials are the same, but the operations between those terms are opposite. All you have to do is square your first term. In this case, for a, it's going to be t times t, which is t squared. Then we're going to have a positive 5 times a negative 5. Remember, those were opposite operations, so we have to take that positive and negative into account. So a positive times a negative is a negative answer, and 5 times 5 is 25. So our answer to A is t squared minus 25. And because of that, because we took the time to look at the terms first and notice they had opposite operations but were the same first term and second term, we can actually just square the first term and multiply the second term, remembering the positives and negatives, and then have our answer. So the other thing I want you to hopefully notice is that every time the answer is going to be subtraction, because the answer to a conjugate has to be minus, because you're always going to, that means you always have a positive and a negative being multiplied, so you're always going to get a negative or a subtraction answer. That's why before I said you square the first term and the last term, I wasn't including the operation in that squaring. So as an example, on B, the shortcut we're looking at is 3x times 3x is 9x squared. Whew, I really messed that up over in our example here. I didn't take 3 times 3, I just kept the 3. Whew. All right, so 9s should have been all around here. There we go. All right, now that that's corrected, now I have y times y, which is y squared, and I'm always going to be subtracting when I have conjugates. So I have 9x squared, always subtracting, and my second term squared.